Welcome to the video lesson for section 7.1, Measures of Center. We're going to look at different centers and identify how they can be used to interpret or represent different data sets. Let's get started. To begin with, let's look at a definition of a measure of center. So the measure of center is a value that attempts to describe the set of data by identifying a center position of the data set to represent a typical value in the set. There are three common measures of center. Let's go ahead and take a look at what they are. To begin with, let's discuss the mean. The mean of a numerical data set is the sum of all the data divided by the number of data values. The symbol x bar is going to be used to represent the mean, and it is read again as x bar. The median of a numerical data set is the exact middle number when the values are written in numerical order. So either in increasing order from smallest to largest or decreasing order from largest to smallest. If we actually have an even number of values, then the median is going to be the mean of the two middle values, which means we would have to average them together to figure out the exact middle. In this case, it's important to note when we're taking the mean of the two middle numbers, that the median will not be an actual number from the data set, whereas if we had an odd number, the median would be a number from the data set. Our final measure of center is the mode, and the mode of the data set is a value or values, there could be more than one, that occur most often. And as I just stated, there could be one mode, no mode, or more than one mode. However, it's important to note that if every number in the data set repeats the same number of times, then there is in fact no mode. Our next term to introduce in this section is an outlier. An outlier is a data value that is much greater or much less than the other values in the data set. So it's either way too big or way too small and doesn't look like it fits the pattern for the rest of the data values. In our example here, we have a table that gives the annual salaries of 8 different employees at an auto repair shop. So we have our table here. We can see that 32,000 represents one individual who earns $32,000. 45,000 would represent an individual that would earn 45,000. We have two questions here. We'd like to find the mean, median, and mode of the data. And then we want to discuss which measure of center would be the best to represent the data. Let's go ahead and work on part A, finding the mean, the median, and the mode. Before I find the mean, median, and mode, I went ahead and I wrote the data in increasing order. And because I didn't have a lot of space, I used some modifications here. So this 32 actually represents 32,000. That's our first data number. And then the 35 represents 35,000. And then we have 38,000, 38,000, 41,000, all the way down to 72,000. So the first thing we would do to find our mean is we would take all of our numbers, so all the numbers in our data set, and I would add all 8 of them together. And if you add them all together, then you end up getting 343,000. And then dividing that by 8. And remember, our notation for the mean is going to be x bar. So x bar is going to equal 343,000 divided by 8. And we get as our answer 42,875. To find our median, I'd like to find the exact middle. So what I'm going to actually do is cross things off. If I cross off a 32,000, I can cross off a 72,000 as well. Then we can cross off 35 and 45, 38 and 42, and I'm left with two numbers. Now remember, because we have an even amount, what we're going to do is add these together and divide by 2. So if I take 41 and 38 and I divide them by 2, then I end up getting 39.5, which is the same as 39,500. So the median number is going to be $39,500. For our last center, we'd like to be able to find our mode. And for our mode, we want to see what number happens most often. By putting all of my values in increasing order, I can quickly identify how often each number occurs. And I can notice that there are two 38s, whereas every other number repeats once. So our mode is going to end up being that value, 38,000. All right, so just to kind of recap here, we found our mean, x bar, by adding up all 8 numbers and then divided by 8. And we got a mean of 42,875. For our median, we wanted to find the middle number. Because there were two middles, we averaged them, and we got 39,500. And then for our mode, we wanted to make sure we found the most often occurring value. Since 38 occurred twice, which is more than all the other numbers, we know that 38,000 is going to be our mode. For our next question, we'd like to identify which of these centers is going to be the best to use when describing our data. Now, one thing we want to notice, The 72 is a little bit bigger than all of our other numbers. And since your mean is an average of all your numbers, that 72, which we might want to consider as an outlier, affects our mean. The mode doesn't necessarily identify a typical value when we have a large spread of values either. So in this case, because we have an outlier, I would say that the median, the 39,500, would be our best number to represent the data. And that was our median. Again, I'm picking the median because it does appear that we have an outlier. And your mode, while it does tell us which is the most often, doesn't always best represent the middle value or a typical value for your data set. We already kind of discussed this, but we want to identify a possible outlier. And so just again, looking at our actual information here, we can see that the 72,000 is so much bigger than all of our other values that it definitely seems to be an outlier, meaning it doesn't exactly fit with all the other data values. And if we wanted to come up with a reason for this, maybe when we're talking about the employees here, that could be someone who has a position above all the rest. So maybe a manager or a president of a company who typically get paid more than all of the other employees for our company. Now we would like to recalculate our mean, but this time we want to do it without the outlier. So our outlier again was at 72,000, and it was a little bit too large. So we're going to see what happens if we take that out. So I'm going to go ahead and add together my 7 values, excluding that 72,000. And if I add those all together, then I get X bar is going to equal 271,000. And this time we're dividing it by 7 because we're excluding that 72,000. And we get approximately 38,714. And remember our X bar before, so our mean before, was equal to 42,875. So the question now is, how did our outlier affect the mean? Well, since our outlier was larger than the rest of the data set, we can see that the mean was in fact larger than if we excluded it. So by taking away a bigger number, our mean went down. If we had a smaller outlier and we took it away, then we'd see the opposite effect and our mean would increase. For example here, we have values 30, 45, we have an x that's unknown, and then 100. We want to try and figure out what x is if we know that the median is going to be 51. Something we have to also assume here is that our numbers are in fact already in the correct increasing order, which means that x is going to be smaller than 100, but definitely bigger than 45. So using our strategy from the last example, if I cross off my 30 and my 100, we can see that the middle two numbers are 45 and our unknown x. To find my median, I'm going to average those two, which means I'm going to do 45 plus x divided by 2, and I'm going to set that equal to 51. I'd like to go ahead and solve for x here. So in order to do that, I'm going to multiply both sides by 2, which allows me to cross off those 2's on the bottom. And I now have the equation of 45 plus x is going to equal 102. And then if I subtract 45 on both sides, I can finish solving for x, and we find out that our unknown value has to be 57. So the only way that we would get a median of 51 is if our x value ended up being 57. All right, we have a similar question here where we have an unknown of x and the same other values, 30, 45, and 100. But now the question is, what is x going to be if the mean is 62.5? So for this problem, in order to find the mean, which we can call x bar, we would have to add together all of our values. So I would take 30, 45, x, and 100, and I would add them all together. And then I'm going to divide by 4 because there are 4 different numbers. And I'm going to set that equal to 62.5 because that is my mean. We can do a little bit of simplifying here. If I add together my 30, 45, and 100, then we get that we have 175 plus x over 4, and that's going to equal 62.5. I now would like to finish solving for x, so I'm going to go ahead and multiply both sides by 4. And the reason why I'm doing that again is I can cancel out the 4 on my denominator. So what I now have is 175 plus x is equal to 250. And then if I subtract 175 on both sides, I get my final answer of x is equal to 75. And for our final example here, we want to know what would x have to be if the mode is 30. So if you look at our values, I have 30, 45, and 100, and then it's unknown. The 30, the 45, and the 100 all occur once, which means they occur the same amount. In order for my mode to be 30, that means 30 has to occur more often than the other numbers. So my 30 would have to occur more than the 145 and the 100. which means that this x is definitely going to have to be 30. The only way I can get my value of 30 to occur more often than the other two values is, again, if this is a 30, because then I would have two 30s, which would be the most often occurring value. All right, that does it for this section. Go ahead and get started on the homework, and good luck.